Hi students, you know that trigonometric inverse function. Now we see some difficult sum of the trigonometric inverse function. See the first sum, tan pi by 4 plus a half cos inverse a by b plus tan pi by 4 minus half cos inverse a by b. We have to prove that is equal to 2b upon a. First we take a left hand side, and in this left hand side, this cos of inverse of a upon b is equal to supposed to be theta. Cos inverse of a upon b is theta. If theta we take it as a closed interval 0 to pi, then your cos theta will be a upon b. Now it is a simple trigonometric sum afterwards. Then it will be a tan of pi by 4 plus, this is theta, so it should be theta by 2 plus tan pi by 4 minus theta by 2. Is that clear? You also know the formula of a tan of a plus b, that is equal to tan a plus tan b upon 1 minus tan a tan b. If it is minus sign, then you have to just change the sign there in the formula. If you apply the formula, then tan of pi by 4 plus tan theta by 2 upon 1 minus tan pi by 4 tan theta by 2. Like this, here also we have to use the same thing. Then it will be a tan pi by 4 minus tan theta by 2 upon 1 plus tan pi by 4 tan theta by 2. Is that clear? But everyone know the value of a tan pi by 4 is a 1. So you can say tan pi by 4 1. So it is 1 plus tan theta by 2 upon 1 minus tan theta by 2 plus 1 minus tan theta by 2. And this tan pi by 4 is also 1. So 1 plus tan theta by 2. Now we take a LCM both the side. The denominator is 1 minus 10, 1 plus 10. That becomes what? 1 minus 10 square. This is a cross multiplication. So here you get it a 1 plus 10 theta by 2. Into the same thing. It's a whole square plus 1 minus 10 theta by 2. Here we expand as a plus b whole square, that is a square plus 2ab plus b square. Here a minus b whole square, that is a square minus 2ab plus b square. Then it becomes 1 plus 2 tan theta by 2 plus tan square theta by 2. Like this, 1 minus 2 tan theta by 2 plus tan square theta by 2. Denominator is as it is, 1 minus tan square theta. You can see this 2 tan theta by 2 cancel. Now you can see the remaining 1 and this 1 becomes 2. But like this tan square plus tan square also become 2 tan square. So 2 plus 2 tan square theta by 2 upon 1 minus tan square. You can take out 2 common, so it is 1 plus tan square theta by 2 upon 1 minus tan square theta. Understand? But see here, you also know the formula for cos theta, that is the 1 minus or cos 2 theta, 1 minus 10 and 1 plus 10 square theta. When it is single theta, it becomes theta by 2, and that formation here also in the form of reciprocal. So it will be like this 2 into 1 upon cos theta. This is nothing but already you have a cos theta is a by b. So 1 upon cos theta will be reciprocal of that. So 2b by b, that is equal to RHS.
Start.
Now see the second sum, that's a different. If a greater than b greater than c greater than 0, these all are positive. But like this bigger, they prove that cot inverse ab plus 1 upon a minus b. Cot inverse BC plus 1 upon B minus C plus cot inverse AC plus 1 upon C minus C is a part. Actually here we have to use one rule. Here cot inverse x. Here you have a two result. If x greater than 0, then we use a tan inverse x. But if x less than 0, then we use a pi plus tan inverse x. Now you can check here a minus b. So a greater than b, so a minus b is greater than 0. B greater than c, so b minus c is also greater than 0. A greater than c given, so here c minus a will be negative. So we use this rule. In these two cases, only simple reciprocal of the term. We convert in a tan inverse. So it will be tan inverse a minus b upon 1 plus a. Like this I am writing also. Tan inverse b minus c. Instead of bc plus 1, I am using 1 plus bc. Because addition is there is no change. But here this term is negative, so we use a pi plus. So plus pi plus tan inverse c minus a upon 1 plus ac. You also know one more rule like that. Tan inverse x minus tan inverse y is what? Tan inverse x minus y upon 1 plus x. This rule we can use from left to right as well as right to left. It is similar form. Right hand side give tan inverse x minus y upon 1 plus xy. Become tan inverse x minus tan inverse y. So here tan inverse a minus b upon 1 plus ab becomes what? Tan inverse a minus tan inverse c. Like this, tan inverse c minus tan inverse plus pi plus tan inverse c minus tan inverse c. You can see this tan inverse a cancel, tan inverse b cancel, tan inverse c cancel. So remaining thing is only pi, that is equal to RHS.
Start.
Now see the third sum is little bit different. We have to prove tan sigma r is 1 to n tan inverse 1 upon 1 plus r into r plus 1 given. We have to prove as a tan inverse n plus 1 minus pi by 4. Now we keep some arrangement in the numerator only for this one. Can we express like this thing? Sigma of r is equal to 1 to n tan inverse. Your denominator is what? 1 plus r into r plus n. In place of this one, we use like this, r plus 1 minus n. So r is cancelled, so 1 is only there, but we keep it as a 1 bracket. Now this form is like that. Just now also I have used this formula tan inverse x minus tan inverse y is what? Tan inverse x minus y upon 1 plus x. So this is also like this. Tan inverse x minus y upon 1 plus xy is equal to tan inverse x minus tan inverse y. So here your x is nothing but what? Sigma is as it is, r is 1 to n. Tan inverse r plus 1 minus tan inverse. Is that clear? Tan inverse x minus y upon 1 plus xy is a tan inverse x minus tan inverse y. But here x is what? R plus 1. Y is what? R. Is that okay? Now we separate the sigma. So sigma r is 1 to n tan inverse r plus 1 minus sigma r is 1 to n tan inverse. Now we substitute the value of r as a 1, 2, 3 up to so on. So first we keep 1, so 1 plus 1, 2. So tan inverse 2 plus tan inverse. If I take a 2, then 2 plus 1, 3. Like this, tan inverse. Up to so on. Last value we keep an n. So last term become tan inverse 1. N plus 1. R plus 1 is n plus 1. What should be the second last term? So can I say tan inverse? Okay, meaning like this. Now we keep here minus, and now we keep r is 1 to n all are positive, but because of this minus sign, all become negative. So first we take r is 1, so tan inverse 1 minus tan inverse 2 up to minus tan inverse 2. You can see this tan inverse 2 cancel, tan inverse 3, 4, all are cancel, tan inverse n also cancel. You will get only two things, one extremely maximum and extremely minimum. Now we keep the value there also, so it is what tan inverse n plus 1 minus tan inverse 1 is nothing but what, and that we can see RHS. Is that? Now see the fourth sum, it's a sign of, prove that sine of cot inverse in cos of tan inverse x is equal to, you have to prove root 1 plus x square upon 2 plus x square. Actually we use this principle, you know that cos inverse y is y. If y belongs to closed interval minus l to 1. Tan of tan inverse y is also y, y belongs to y. Sine of sine inverse y is also y, but y belongs to closed interval minus 1 to 1. So this cos of tan inverse, so this tan inverse we try to change by using right angle triangle. See, if I take tan inverse x for right angle triangle, this angle then opposite side upon adjacent side. So hypotenuse becomes what? Root of x square plus. Now we have to turn in a cos. So can I say sine? The rest thing is same. Cos. Cos inverse what? So say adjacent upon hypotenuse. So 1 upon root 1 plus x. Now this cos of cos inverse y becomes y. So this you can see. Sine of cot inverse 1 upon root 1 plus x. Now this cot inverse we have to turn into sine inverse. So again we use a right angle triangle. Cot means adjacent side upon opposite side, 1 plus x. How you get it hypotenuse? So sum of the square of this, so it should be 1 plus 1, 2 plus x square means root 2 plus x square. Now this calculation everyone knows. So sine of remaining is what? Sine inverse opposite side upon hypotenuse, so root of 1 plus x square upon root of 2 plus x square. The sine of sine inverse y is a y, everyone know. So that is a common root 1 plus x square upon 2 plus x square. That is equal to RHS. Is that okay? Now see the fifth sum. It's a little bit similar one to the fourth, but a little bit lengthy here. Cosec, tan inverse, cos, cot inverse, sec, sine inverse a. We have to prove root 3 minus a square. We use the same principle. Cos of cos inverse y is always y if a y belongs to closed interval minus 1 to 1. So here we use the same kind of a logic only. See cosec, tan inverse, cos, cot inverse, sec. See sine inverse a given. So first we use a right angle triangle. Sine inverse means opposite side upon adjacent side. So this should be what? 1 plus a square. Oh, sorry. Sine inverse means what? Opposite side upon hypotenuse. So this should be 1. So adjacent side become what? Root of 1 minus x. So we want to convert the sine inverse into sec inverse. So we can say sec inverse adjacent side, or you can say hypotenuse upon adjacent side. So it should be 1 upon root 1 minus x. This that be okay. Now the sec of sec inverse y becomes what? Simply y. So again I use cosec, tan inverse, cos, cot inverse, or we can say 1 upon root 1 minus x. Now again we use the right angle triangle. Cot means what? Adjacent upon opposite side means 1 is root of 1 minus a square. Sum of the square of these two means it is the root of 2 minus a square. And this cot inverse you will turn into what? Cos inverse. So we also can say cosec tan inverse cos inverse. Tell me. So say adjacent upon hypotenuse means 1 upon root of 2 minus x square. Again this cos of cos inverse becomes what? 1. So cos inverse y is y. So cosec tan inverse, you can say 1 upon root of 2 minus x square. Now again we have to turn this tan inverse into cosec inverse. So first we represent on a right angle triangle, opposite upon adjacent side. Hypotenuse is sum of the square, so it is a 3 minus a square. Is that clear? Now we have to tan inverse turn into cosec inverse. So it is cosec inverse root of 3 minus a square. Is that clear? Now cos of means cosec of cosec inverse y is 1, means it is nothing but root of 3 minus a square. That's okay. See, the next question is little bit different. If 0 less than x less than 1 and the tan inverse 1 minus x, tan inverse x, tan inverse 1 plus x are in AP, means they are in arithmetic progression, then prove that x cube plus x square is equal to 1. So here first we take it the statement tan inverse 1 minus x, tan inverse x and tan inverse 1 plus x are in AP. You know logic, if A, B, C are in AP, then we say that to be equal to what? A plus C. Suppose A, B, C are in AP, we write as a what? To be equal to A plus C. So here, this A, B and C. So 2 times middle term means what? Tan inverse x is equal to, can I say tan inverse 1 minus x plus tan inverse. Understood? This 2 tan inverse x can be expressed as a tan inverse x plus tan inverse x is equal to, as it is tan inverse 1 minus x plus tan inverse. See, we have to use simply the rule of tan inverse x plus tan inverse y is what? Tan inverse x plus y upon 1 minus x. So here you can say tan inverse x plus x upon 1 minus x into x. Similar way, tan inverse, it should be 1 minus x plus 1 plus x upon 1 minus x into x. I hope you clear about this. See, here you can also make a note, 0 less than x less than 1. So therefore x square is smaller than 1. So therefore 1 minus x square is smaller than 1. Okay. So this product will be smaller than 1. So we are not using their pi. Now tan inverse is 1 function in a specific interval. So we can express as a 2x upon 1 minus x square is equal to this x cancel. So 2 upon 1 minus x. This 2 will be also cancelled. So x upon 1 minus x is equal to 1 upon 1 minus 1 plus x. This 1 cancel. So again, x upon 1 minus x is 1 upon x. Cross multiplication. So this x square comes here. So this x cube is equal to 1 minus x. So you can also say x cube plus x square is equal to 1. That's it. See, this is another method. So this is another method. If a tan inverse x plus tan inverse y plus tan inverse z is equal to pi, then prove that x plus y plus z equal to x, y, z. We here take it, suppose tan inverse x is alpha, tan inverse y is beta, and tan inverse z is gamma. Where this alpha, beta, gamma belongs to closed open intervals minus pi by 2 to pi by 2. So inverse is possible. Then you can say that tan alpha is x, tan beta is y, and tan gamma is z. See, I just repeat the question. What here given? Tan inverse x plus tan inverse y plus tan inverse z equal to pi. But tan inverse x is alpha plus beta plus gamma is equal to pi. If I take gamma that side, so alpha plus beta is pi minus gamma. We take both the side tan, so tan of alpha plus beta is tan of pi minus gamma. We apply the rule tan alpha plus beta means what? Tan alpha plus tan beta upon 1 minus tan alpha. See, tan pi minus gamma. Pi minus means second quadrant, tan negative, so it should be minus tan. We take denominator that side, so it will be like this. Therefore, tan alpha plus tan beta is equal to minus tan gamma in bracket 1 minus tan alpha. If we expand, then it should be what? Minus tan gamma plus tan alpha tan beta tan. Minus tan gamma, we take this side, so it will be like this result, trigonometry, tan alpha plus tan beta plus tan gamma equal to tan alpha tan beta. If I keep the value of tan alpha beta gamma, let's say x, y, z, so it is what? X plus y plus z. Okay.